Particle starts from rest and moves in a horizontal line. Its speed is given to you by the following equation. Oh, its speed v at time t is given by the following equation. Find the time taken for the speed of the particle increase from 25 to 75. Okay, so I'm going to go for 1 over, bring the 100 minus v underneath. That equals the t. Huh? Oh, sorry, this t. Thanks. My mind was trailing on me. Integrate from 75 to 25, isn't it? Okay. And that's just 1 to t. From 0 to t. Start the clock at 0. So 0 corresponds to when it's already moving 25. You're only after the difference from 25 to 75, even though it starts at rest. Okay. What function do you think we should use for this? To get this, it's a linear on the bottom. So what happens if it's a linear on the bottom? Pretty sure you can use ln. So you use ln 100, take away v. Differentiate this. What happens when you differentiate it? Differentiate the part in the bracket, and you get minus 1 divided by the derivative of what it is, which is the minus 1, which basically makes it minus ln 100 over v. Sorry, 100 minus v. And then what do we have from there? 75 and 25, and the other side is just t from t to 0. Let's get a t here. I believe I'm going to have minus, when it's 75, it's 100 minus 75, it's going to be minus ln 25, plus, 2 minuses make a plus, plus ln 75. Use the subtraction rules of logs. And what's the subtraction rules of logs here? Ln 75 over 25. We should get ln 3. Can anybody give me ln 3 in decimal? 1.098. Any questions thus far? How far does the particle travel in going from rest to 75? Answer to 2 decimal places. Now, ds dt. All right. The one's how far from rest to. So I wanted to go from rest all the way up. So there's sort of more than one way of doing this. I might show you the 2 different ways of doing it if there is 2 different ways. Here's what we're thinking. Just while I'm here, I'm thinking about going back to this initial question. Ever see the initial question? I'm thinking about just turning that into 0. And I could find the time taken that way, couldn't I? And then somehow relate it to the distance using dSdt. But maybe the quicker way to do this would be, if you look at the variables, the variable is how far, which is distance related to speed. You have to relate the distance to the speed, don't you, according to the question? Because that's a speed, and how far is a distance. So replace the VDT with what, guys? The VDS or the VDX. I'll use the VDX because my S's look like waves. Okay? And I'll do 100 minus V. Then I'll bring V over 100 minus V. v equals dx. Does anybody remember how I did this last time? I did a u substitution. What was my u substitution? U is 100 take away v. But that logic, v on its own is what? 100 take away u. Is that right? So, what does that mean? Actually, before I did that even, I should have done du dv. See this part here? Differentiate. What happens when you differentiate it? You get -1. And you get du equals minus dv. Yeah? Or dv equals minus du. So let's take this apart. What am I replacing this with? Anybody? Minus du. What am I replacing this with? U. What am I replacing this with? 100 take away u. Okay. Now that we've established all that. Okay, here's what I'm going to do. Do you see that minus? You see this minus? I'm going to multiply it by all at the top. How does that minus affect 100 minus u? What does it do to it? Sorry, don't know what happened there. All right, yeah. What does it do to it? U minus 100 over u. For God's sake, I'm still in. Still in there. Now we can finally do this. What's u over u? 1 minus 100 over u, which is technically 100 times 1 over u. Du. And the other side is dx. Now, what should be my limits in this question? Can anybody tell me? I won't do limits here. Can anybody explain why? Why won't I do limits in those two blue ones? Yeah, I'm going to change it back in a minute. And what about the other side? Well, 0 and x. Yeah, we'll do it that way. What do we get then? X from x to 0 equals x. And what happens when I integrate this? U. Integrate 1, it's u. Integrate 100, it's 100. Integrate 1 over u. What do you think? ln u. Great. Well, what is that again? What do we say u was again? 100 minus v. So it's 100 minus v minus 100 ln 100 minus v. And that is from, what two speeds did they give me again? 0 to 75. So that's going to be annoying. So I'm just going to put 75s here initially. So that's going to be 100 take away 75 is 25 minus 100 ln 25 take away, and this time it's going to be zeros, so it's going to be 100 minus 100 ln 100. Now what does it want from me here? I don't even know why I'd bother breaking this down. I'm not going to. Put it all in the calculator and see what you get. There's no point in making this look fancy. All those numbers are calculatable right now. So everybody throw all that into the calculator and tell me what you get. So we throw it all in. No need to make this look fancy. 63.63 equals x. Everybody cool with that? Now part 3. Determine the limiting speeds, that is the speed as t approaches infinity. Okay, now we're going to go back to part 1. Part 1 was all about the v and the t. Remember we did that earlier? Okay. So does anybody remember what we did earlier with this? With part 1, we found out that it was 1 over 100 take away v. The v equals to t. And technically I can go from 0 to, we go 0 to infinity if we want, can't we? Would that be right? For the time being, I won't go straight to infinity. It just seems weird. I'll go to t. And the deal is, I don't know my v values. 0 to v, yeah? What did we say earlier? It was minus ln 100 minus v from v to 0. And the other side just ended up being t, wasn't it? And this was minus ln 100 minus v plus ln 100, because v is 0 on the second go. I can probably turn that into a negative log row. So what do you think? ln 100 divided by 100 minus v equals t. Bring up the e value, get rid of the ln, yes? The ln 100. Oh yeah. So when you integrate 1 over x, it turns into when you integrate that, it turns into ln x. But if I was to integrate, for example, ln over 3x, it'd be 3x, then it'd be divided by the derivative, which is turns out the same. But then when it's an unusual one, let's say for example this one here, where it's ln 5 minus 3x as an example, the answer to that question would be ln 5 minus 3x, differentiate that part, minus 3, so there'll be actually a minus 3 on the bottom. In this case, it was a minus 1. We did it in part 1. That's why I sort of took shortcut liberties there. Now, what do I do with the e, guys? Throw the e up, yeah? So what do we get? Well, yeah, so I'm going to get 100 over 100 minus v e to the power t. I'm going to do a switch here. So, if you will, I'm going to switch the et and the 100 minus v. Both of them are going to switch positions. The two green ones are going to switch positions, okay? And what will happen there is it's going to be 100 over e to the t, which we all know is 100 e to the minus t equals 100 minus v. Minus v to the left, 100 e to the t to the right. And what we're going to get is v equals 100 minus 100 e to minus t. Now what happens as t tends to infinity? What happens to any negative power? As t approaches infinity, this guy here approaches 0, so your final velocity is 100 meters per second.